that we can see what is the encoding circuit for a n by k for an n by k cyclic code. So this figure shows the encoding circuit for an n by k cyclic code with generator polynomial g of x equal to 1 plus g1x plus g2x square plus up to x raised to n minus k. So we can see that what are the steps for this steps related to this encoding process. So this for an n by k cyclic code in systematic form we are going to see. So we have the systematic form representation as well as non-systematic form representations are there. And in systematic form we can identify where is the parity bit and where is the message bit. That's the difference. That is the only difference between this systematic form and non-systematic form. So for generating the encoding for encoding purpose encoding of an n by k cyclic code in systematic form, it consists of 3 steps. One is multiply the message polynomial u of x by x raised to n minus k. So whatever be the given message signal, you must first multiply it with x raised to n minus k. Then divide this x raised to n minus k u of x by g of x to obtain the remainder b of x. Then after multiplication of this u of x by x raised to n minus k, you need to divide that step 1 result with g of x. Then you will get the remainder b of x, and form the code word b of x plus x raised to n minus k u of x. All these 3 steps can be did with a division circuit which is linear n by k n minus k stage shift register with feedback connection based on the generator polynomial g of x is equal to 1 plus g1x plus g2x square plus up to x raised to n minus k. So we are doing 3 steps in this encoding process. First, our message polynomial, suppose the message polynomial is u of x, then we need to multiply it with x raised to n minus k, then divide that u of x into x raised to n minus k by g of x. Then we are finding the remainder. Then this remainder plus x raised to n minus k into u of x will be the systematic form of our message, our coded information. So this all 3 steps we are doing using a division circuit that consists of linear n minus k shift registers with the feedback connection. So that's shown in this figure. So we can see what is the working of this figure. So first step, with the gate turned on, the k information digit. So first with the gate turned on, the k information digit u0 u1 up to uk minus 1 or u of x is equal to u0 u1 x up to uk minus 1 x raised to k minus 1 in polynomial form are shifted into the circuit and simultaneously into the communication channel. Shifting the message u of x into the circuit from the front end is equivalent to pre-multiplexing u of x by x raised to n minus k. As soon as the complete message has entered the circuit, the n minus k digit in the register form the remainder, and thus they are parity check bits. Break the feedback connection by turning off the gate, shift the parity check bits out and send them into channel. This n minus k parity check bit b0 b1 up to bn minus k minus 1 together with the k information digit form a complete code vector. So we can see the working principle of this encoding circuit. So this, if we given the message signal to this feedback circuit, that means that process is equivalent to this message polynomial is multiplied by x raised to n minus k. So at the same time we are giving that message to the communication channel also. So as soon as getting this message, this register, this feedback circuit will calculate what is the remainder by dividing this x raised to n minus k u of x by g of x. So this b of x after the further shift, this b of x is we will get from this register, and that b of x and this message signal we will send to the communication channel. So this way we can see the encoding of cyclic codes. And this is in the systematic form. So this is the encoder for systematic form. That means we can differentiate where is the message and where is the parity check bits.